Imagine I give you two boxes. One box is stack, another box is also a stack. Now I ask you to build one queue. Wait, a queue and a stack behave completely different. A queue removes the oldest element first, and stack removes the newest element first. So how can two wrong tools uh, somewhere create a right tool? That's exactly what LeetCode 232 asks us to do. And the trick behind this question is surprisingly clever. Before solving the problem, let's understand the challenge. A queue allows FIFO, first in, first out. Think of the people standing in a ticket line. The first person to enter the line leaves the first. Mm, Just understand in more layman language. If you are standing for a movie ticket, so you've seen a line for a movie ticket or any line, the first person standing will leave first. That's how a queue works. Example, 1 enter, 2 enter, and 3 enter. Queue removes first 1, then 2, then 3. A stack flow is LIFO, last in first out. Think of a stack of plates. The last plate placed on the top remove the first. Example, 1 enter, 2 enter, 3 enter. Stack removes the first, then second, then first. So the interviewer basically asking, can you build a FIFO structure using LIFO structure? At first glance, it sounds impossible. Suppose we use only one stack. Push 1, push 2, push 3. Stack becomes 3, 2, 1. Now you want to remove 1, 3. You want to remove 1, but the stack gives 3. Wrong answer. One stack isn't enough. That what if we use two stack? Let's call them input stack and output stack. The idea, whenever someone enters the queue, simply place them input stack. Push 1, push 2, and push 3. Input stack look like 3, 2, and 1. Now suppose somebody want to leave the queue. Queue say remove 1, but the top input stack is 3. Still wrong. What happen if we move everything into the another stack? We move 3, 2, 1, and the output stack become 1, 2, and 3. Something amazing just happened. The order reversed in the output stack. Now, the top element is 1, exactly what a queue wanted. To reversal created FIFO behavior. Pause the video for 5 seconds. If the output stack already contained element, do we need to transfer everything again? Think about it and answer yes and no in the comment section and then see the answer. The answer is no. We only transfer element when the output stack become empty. But why? Because the correct order is already waiting inside the output stack. No need to repeat the work. We can understand from the example when if we push one, let's see here. If we push 1, push 2, and push 3, so our input stack look like this. This is how our input stack going to look like. Pop, output stack empty. Transfer all the element to the output stack. If we move all the element to the output stack, then this is our output stack. Remove one. Pop again. The output stack become After popping one, we output stack become 2 and 3. That's it why the solution is efficient. Element move between the stack only when necessary. So let's say this inside the code. Let's connect the code to the story as we pass the test case. Two stacks, stack in input stack and stack in output stack. One stack receive elements, another stack receive stack serves element. Push input stack push X element always enter the input stack simple. Pick if output stack is empty, if output stack already has an element, use them directly. While not in not input stack dot empty, this is the magic step. Move everything from input stack to output stack. Reversal. Each traverse reverse the order. Each transfer reverse the order. And that's what the create a queue behavior. Remove the front element from the queue. If both stack are empty, the queue is empty. Most beginners think this question is about stack. If you think about its transform, can you use one data structure to simulate another? That's the real reason. The time complexity is O of one, and space complexity is also O of time complexity is O1 for push, pop is O also O1 and peak O1. Space complexity is O of n ending. I want to say that the sweet code problem 320 through 332 at the first building a queue using a stack sound impossible. But once you realize that screw traversal restores the original order, the entire problem becomes elegant. The key idea is simple. One stack stores incoming element and second stack serves the outgoing element. And together they perfectly mimic a queue. If this explanation helped you, see this hidden trick, hit like and subscribe and comment the next week of problem you would like to solve together. See you in the next one.